All right, I want to look at chapter 7 here of Algebra 1. Starting off, we're adding and subtracting polynomials. So right now, I don't think that we have a definition of a polynomial yet. But we start off with a really simple polynomial. It's called a monomial, right? Mono meaning one. A monomial is a number, a variable, or the product of a number and one or more variables with whole number exponents. All right, that's kind of a big deal right there, whole number exponents. So some examples of monomials. The number 5, right? The number 5, that is considered a monomial. We could also say 5x. That would also be a monomial, right? It's one piece, okay? Now, if we were to say 5 plus 5x, that is not a monomial anymore because there's two separate terms, two separate pieces, right? We have a monomial and a monomial. Together, they're a binomial, but we're not really getting to that word yet. But we have two separate monomials here. Oftentimes, especially in Algebra 1 when we're dealing with this, we will only have one variable. But technically, we could also say something like, I don't know, 5xy, right? That would be also a monomial. It's a monomial with like three little pieces there, the 5, the x, and the y, but it's still a monomial. Something that we can't have would be something like 1 over x, right? That does not work. Or x to like a negative exponent, right? Like -5, right? We haven't dealt with negative exponents much, but that also does not work out here. So after the definition of a monomial, we have the degree. So the degree of a monomial is the sum of the exponents of the variables in the monomial. The degree of a non-zero constant term is 0. The constant 0 is considered to not have a degree. So looking up here, if we look at our 5, its degree is 0 because it doesn't have a variable, it doesn't have an exponent, right? Its degree is 0. 5x, its degree would be 1. And the way that I think about that is that we have this is like an x to the 1, so that exponent of 1, that is the degree. For this guy here, we have more than one variable, so we actually have to add up the exponents of the variables. The x has an exponent of 1, the y also has an exponent of 1. Together they have a degree of 2, okay? So let's look at example 1 here. We're supposed to find the degree of this. Because it has more than one variable, we're going to have to add up their exponents. So we're going to say, well, 2 plus 3 gives us 5. Okay? If the problem said something like, I don't know, just 2x cubed, then the degree would be 3, right? That's a little bit easier there. But when we have the multiple variables, we have to add up those exponents. Okay, that is the degree. All right, looking at a polynomial now. So everything we just talked about were monomials. Now a polynomial is a monomial. It could be just one, or it could be a sum of monomials. Each monomial is called a term. Think about the word term meaning like it's a separate piece, right? A polynomial with two terms is called a binomial, right? Bi meaning two. A polynomial with three terms is a trinomial, okay? After 3, we normally don't have a fancy word. We just say it has 4 terms. It has 5 terms. So the words that we need now, the words that we will need to know are monomial, binomial, and trinomial, right? Mono is 1, bi is 2, and tri is 3. All right, so that is a polynomial. Polynomial is a string of them, a string of monomials added together. The degree of a polynomial is the greatest degree of its terms, right? So we talked about degree with a monomial. So for a polynomial, you'll look at a bunch of different pieces and you'll pick out the one with the highest exponent, the highest degree. So continuing on right here, a polynomial in one variable is in standard form when its exponents of the terms decrease from left to right. When you write a polynomial in standard form, the coefficients of the first term is called the leading coefficient. So look in here. This is a polynomial with 4 terms in it, right? Because it has 4 pieces. 1, 2, 3, and 4. And then we can look at their exponents, right? This first one has an exponent of 3, exponent of 2, an exponent of 1, and then really there's no x, so that last one is like degree 0. You could think about this being an x to the 0 if you wanted to. All right, 3, 2, 1, 0 is our exponents. Its degree, this polynomial's degree, is the biggest exponent. Its degree is 3 here, right? Because the 3 is the biggest exponent, the biggest degree. The 2 is the leading coefficient because it is the, if you look at the first term, right, the term with the highest degree, its coefficient, right? And the coefficient is the number sitting out front. So there we go. This one's degree is 3, and its leading coefficient is 2, right? And we could also say that it has 4 terms, right? Because it has 4 pieces. All right, next up, example 2. Write blah in standard form, identify the degree and the leading coefficient. So starting off, we want to write him in standard form. Highest exponent first. I see that this one has an exponent of 3, then we have an exponent of 2, and then we have no exponent. So we're going to write the one with the 3 first. 5x cubed minus 4x squared, and then minus 1. So now that is in standard form, right? We notice that the 5x cubed there is positive, so he's positive down here. The negative 4x squared is negative, so he's negative down there. And then also for the negative 1, negative 1. So that's our polynomial in standard form. And then we want the degree. The degree is 3. That's the biggest exponent. And then the leading coefficient, it is 5. That's the very first number that we see. And that's that. All right, next up. We're going to be looking at adding and subtracting them. So first off, we have this idea here. A set of numbers, right? A set is a grouping. A set of numbers is closed under an operation when the operation performed on any 2 numbers in the set results in a number that is also in the set. Okay, and the one that we're going to think about is the set of integers. So we're going to say, like, if you take 5 plus 3, right? 5 and 3 are both integers. That gives you 8. And 8 is also an integer, right? Addition of integers is closed, meaning that you add 2 integers, you get another integer. Hopefully that makes sense to us. We're going to see that with polynomials, addition and also subtraction are closed, meaning that if you add up 2 separate polynomials, you get another polynomial. And if you subtract 2 of them, you get another polynomial, okay? This also works for multiplying, but it doesn't work for dividing. So we want to look here. I'm going to scroll on down to example 3. Now, a lot of this you're going to recognize just from combining like terms that we've done in the past. We have a plus there. The addition ones are a little bit easier. We just get to drop our parentheses. So I'm just going to copy it down without the parentheses. 5w cubed minus 2w squared plus w plus 4w squared minus 3w cubed minus 5. And then in my next step, I want to do 2 things. I want to combine like terms, which we should be familiar with, but I also want to write him in standard form, right? Highest exponents first. So I'm going to look for my highest exponent. It looks like it is a 3, so I'm going to have 5 and negative 3. That gives me 2w cubed. And then I'll look for another one. After 3, I get 2, so degree 2 is right there. Negative 2 and positive 4 gives me 2w squared. Now I have plus just a plain old w. There's nothing to go with him. And maybe I can write that a little bit nicer. And then lastly, we have the minus 5 on the end. Okay, that is our new polynomial. Right? We added up 2 of them, and oops, we got a new one. There we go. Now, for part B here, we are subtracting, right? In the first one we added right there. Now we are subtracting. With subtraction, it's a little bit more difficult, and there's just one extra step. We have to kind of distribute a negative. So we think about this being minus 1 right there, and then we're going to distribute that negative 1 to these 3 pieces. So the beginning, he just stays put, so we'll say 5q squared minus 2. And then I'm going to distribute that negative 1. To the first piece, I get a positive 3q squared. Then I get a minus 4q. And then I get a plus 3. Right, I just multiplied those 3 terms by negative 1. Now, it's just like part A, and I combine like terms. So I look for my highest exponent. It is a 2, so I'm going to add those guys together. and I get 8q squared. Next up, we'll have plain old q's, so this will be negative 4q. And then I've got negative 2, and positive 3 gives me plus 1. And there we go. That's my polynomial. Okay. Addition, subtraction, quite easy. You're just combining like terms. And then something to not forget about is whenever you have the negative right there, you've got to distribute the negative 1. Okay. This should be very easy. It should be very, I don't know, just this is stuff that we should have been doing for over a year now. All right, scrolling on down. Example 4, find the degree of this monomial. Well, we remember that if there's more than one variable in a monomial, we have to add up the exponents. So right here, this is a monomial because there's just one piece, right? There's no addition, no subtraction. There's just one term. So now we take the 2 plus 5, right? Those are our exponents, and we get 7. And that is our degree. All right, example 5. This is similar to a problem we did, I think, on the front page. We're going to write him in standard form, and then we're going to identify the degree and the leading coefficient. So writing this in standard form just means putting the exponents in order. So I'll say negative 4h cubed. That's the biggest exponent. And then I have my plus 5h. And then lastly, I have my negative 2, and it has no exponent, right? This h, we always remember there's a little invisible 1 there, right? The understood 1. So now this is in standard form. The degree is just the biggest exponent, that is 3. And the leading coefficient is negative 4. And there we go. All right, that is section 1. Things to remember. We got the word polynomial. Polynomial is a grouping of more than one monomial, right? And then we remember what a monomial can be, right? We have numbers like we've seen before, 5 and 5x, right? Those are monomials. A little bit more complicated here is in the green where we have 5xy. What we cannot have is 1 over x. We can't have that, and we also can't have x to a negative exponent. Okay, we cannot have those. All right, that is section 1.